Welcome to topic 1 of ethical hacking, and this topic is malware and types of attacks. And we've got a graphic here that shows malware, and then we've got some different examples of attacks around about. So we've got bad password, spam, Trojan, crack. I suppose these are types of attacks. These are just words that are associated with malware. Okay, so where does malware actually come from? So mal is short for malicious, and ware is from software. So we have mal, okay, and ware, we have malicious software. And this is used to describe computer code that has been written with the intention of causing harm to computer systems. So anything that's designed to cause harm can be considered to be malware. And this is an umbrella term, which means it encompasses a lot of different types of malicious software. Okay, malware isn't just one thing. There isn't just one type of malware. There are lots of different types of malware. Now, the destructive effects of malware can range from very mild inconvenience, such as making somebody have to log out and log in again. That might be marginally annoying, moving up to something that's highly malicious, something severe, breaking whole computer systems down. Okay, now people often refer to any type of malicious program as a virus. Okay, but technically that's not correct. Okay, a virus is a particular type of malicious program, and it's a type of malicious program that has the ability to replicate itself. Okay, just like a human virus. All right. So technically, calling all types of malware a virus is wrong. Now, the different types of malware range from viruses, trojans, worms, ransomware, and each of these have their own characteristics and behaviors, which we'll look at in this course. Now, some malware might have behaviors of two or more of the different types of malware. So some malware might be ransomware, but it might also be spyware. Okay, it might be a Trojan, and it might have some other function as well. So now throughout this course, you might see like a level 5 or a level 6 or a level 4. This is because this material wasn't written by me. It was created by the SQA for this course. And because you guys are doing the level 6 version of this course, sometimes you'll see level 5 and level 4 in here. We need to know all of it. Okay, so the definition we have here for a virus is a piece of code that's written with the intention of disrupting the normal operation of a computer system. Like a biological virus, it can self-replicate. And when the host file of the virus is loaded onto a computer, that computer is considered to be infected. And these viruses can spread to other computers in any number of ways. But in order to do some, to spread, they usually require some sort of user interaction. Someone has to do something to download or copy the virus onto the computer. So we've got some methods down here where viruses can be brought into a system. So the backing storage. Now, this is something I don't call it the backing storage. The backing storage just means some sort of storage device. Okay, a USB drive, a hard drive. We would probably call it a removable hard drive or an extra hard drive, or an internal hard drive. Okay, email attachments are a common way of spreading viruses, and clicking on something on the internet. Okay, so what are the symptoms of a virus? If your computer's been infected by a virus, it may exhibit some symptoms of things popping up on the desktop, or you know, certain behaviors that are against the characteristics of the computer. Now, many people might not know that they have a virus. They might just be what I would call an unconscious agent, a zombie, carrying a virus without knowing about it. So, here are some examples of things that can happen. So, an error message that pops up saying, you know, you must update, you must do this, you must do that. Slow performance, you might notice a degraded speed, files missing or inaccessible programs, unusual hard disk activity. You might hear the hard disk spinning or making a noise. Now, that's not so common if you've got a solid state drive. But if you, in the old days when we had mechanical drives that moved, you could hear it going like, you could hear the actual hard drive, you could hear the platters spinning. That's not such a common thing now. So, unusual behavior, such as windows opening or closing, and then suddenly rebooting and shutting down as well, may be a symptom. So, here are some types of virus. We can have a file virus, a macro virus, or a boot sector virus. So a bit of an explanation on each. A file virus is embedded inside a file. Typically on Windows, it would be an exe file, but we could have a virus inside a doc file or a PDF. And the virus can spread itself once it's been copied onto the computer. A macro virus is a virus that's built into a macro. Now, a macro is not such a common term these days, but a macro it's a way to automate tasks inside a program such as Excel. If you have to do something 100 times, you could create a macro to do it. And a macro virus is something that's hidden inside a macro. Boot sector virus occupies part of the disk that the computer accesses to start up. Okay, the boot sector of the disk. Right, virus behaviors. So some virus behaviors include replication, being able to spread and copy itself, watching. Okay, some viruses sit and wait for a particular date or time in order to be triggered. Okay, and at that point, the virus will suddenly be executed. And camouflage is another facility. So virus is able to disguise itself in your computer as a potentially harmless file. If you don't know what you're looking for, you would not be able to identify where the virus is. Finally, delivery. This is known as the payload. So when a virus sits, it may sit dormant on your computer until a certain date or time or some event triggers it, at which point the payload is released and the malicious code in the virus runs. Now, it says here, viruses can have very low effects, such as practical jokes, to very serious data destruction. Okay, and you know, these viruses come from different. There can be different actors that have different motivations, and that's something that they look at in the data security module. But also we look at that a little bit later on in this subject. So antivirus software. The growth in viruses and malware developed a need for software called antivirus or anti-malware software. Now, I think anti-malware software is a bit of a better term because it covers not just viruses, but things like trojans and worms and spyware as well. Okay, ransomware, spyware. Now, how does antivirus software or anti-malware software look for malware on your computer? Okay, so we've got three different methods. Okay, the three most common methods. The first one is called memory resident monitoring. Okay, now Some antivirus software is constantly resident in memory and actively monitors the system for viruses while the computer is running. Okay, so what it does is it scans the system and it looks for things that are sitting in the memory. Okay, and it runs scans over the system. Now this may slow the computer down doing this. Then we have a heuristic detection. This is the technique of applying the previous experience to a problem. I don't know if that's very well explained. What this actually means is it means it looks for suspicious behavior. So it knows how some viruses behave, what they do, and if it sees that behavior, it knows to quarantine the virus or alert the user. Okay, and finally, signature detection, probably the simplest. On the internet, it's easy for an anti-malware program to download a giant list of the digital signature of known viruses. And all the antivirus program does is it keeps a database of these signatures and it scans your computer. And if it finds one that matches the signature of a virus, it flags it up to you. Okay, so probably the most simple of the three there. Right, checksums. So viruses often attach themselves to program files so that when a program is launched, the virus is launched along with it. So this is probably a good time to show a little example of what a checksum or hash might involve, rather than just reading it off. So it's saying here that a checksum is calculated in such a way that a tiny difference in a file will result in a radically different value. So let me just give you a demonstration of this just now. So here is my computer here. I'll just make the font a bit bigger so it's easier to see. So it's this one. Let's just turn up the font, right? Okay, so I'm going to make a file, okay? So I'm just going to make it with the VI editor, my file 1. Okay, and inside my file, I'm going to put a message called secret message. Okay, I'm going to save that file. Okay, so now if I list out my file 1, if I do cat to show the contents of my file 1, you'll see inside there is a secret message. Now, I'm going to run a command called md5sum, okay, on my file 1. An md5sum is going to return a hash signature, okay, which is this value here. Okay, now, this value is calculated by some algorithm. Some mathematical calculation is run on the binary level of this file, which generates this. And this can be permissible in a court, okay? We can take this signature and then we could take this to court and we could show that signature and show that file, and that would prove that the file hadn't been changed. Now, if I copy my file 1, okay, and I make a copy of it called my file 2, okay? So let's just show you what's in my file 2. It's an exact copy of my file 1. Secret message is in there. So let's cat my file 1 as well. Secret message. So we've got two identical files called my file 1 and my file 2. Okay. Now, here is the hash signature for my file 1. Now, do you think if I run md5sum on my file 2, it will have a different hash signature, or if it will be the same? Just think to yourself, will this be different or will it be the same? Okay, so I'll run it now. And you should be able to see, just by if you count back the last few characters, that it's actually the same. Okay, let's run them side by side so we can see my file 2, my file 1. Okay, there they are there. So you should be able to see that these numbers, this number and this number, are the same. Why are they the same? The reason they're the same is because the file name doesn't matter. It's what's inside the file that generates the signature. Now, let's say I go into my file 1, okay? So let me go into my file 1 and let's add, okay, a space to the end of secret message and save. Now if we run the MD5 sum, look at the number now. It's completely different from this number. This one starts with a 2, this one starts with a 7. This one's got A5, that's got 64. The number is completely different, and that's just by adding one space to the file. Now, if I was to go to my file 2, all right, and I was to add one space, and then we were to do an MD5 sum, those are now identical. So a hash sum or hash signature is a way of creating a digital signature of a file, and we can check if a file has been tampered with. So if I said to you, I'm sending you over a file, and here's the MD5 key, the MD5 hash. When the file arrived at your computer, if you check the MD5 hash, then you should be confident that that file hasn't been tampered with. Now, there are ways around this and stuff, but for now, let's just accept that that shows that the file hasn't been changed. Now, there are other hashing algorithms, okay? There is a SHA-512 sum, okay? And this gives a very big number. Okay, look how long that number is there. There's a SHA, if I double tap tab, there's all these different sums here. There's a SHA-224 sum, okay? My file 2. Okay, it gives a not so big number as a 512 sum. Now, SHA just stands for the secure hashing algorithm, okay? This 224 will be the number of bits. Okay, there's a SHA-384 sum, okay, gives you that. The reason that we use MD5 sum, okay, which stands for Message Digest 5 sum, is because it's easy to read. Okay, this is only 32 characters. All right, so it's easy for me to show you the difference between two of them. It's easy for us to see with our eyes. If I was to start showing you SHA-512 sums, then you'd be like, wow, this is going to be really difficult for me to read because look how long the number is. Okay, so that's just a little bit about hashing algorithms. Often, when you're given a piece of software, we'll show you, you'll see the hash as well, and you can use the hash to verify, to see if the file has been changed. Okay, and this is important if you're doing a digital investigation as well, to take hashes of all of the disks that you have, so you can prove in the court of law that these haven't been changed. All right, so Trojans, right. A Trojan is a type of malware that's disguised as something else in order to trick users, okay? Now, Trojans don't self-replicate in most cases like a virus, okay? They rely on their disguise, they get into a computer system, and then they release the payload, okay? And this comes from an ancient Greek story, okay? Now, a backdoor virus or a backdoor is a way of getting into a computer other than the conventional method of accessing it, some trick way of sneaking in. And we'll learn how to do this to a computer later on in the subject. A worm is similar to a virus in that it can replicate a working copy of itself, okay? But in contrast to a virus, worms are standalone software and they don't require some host program or some help to propagate. A worm can split itself and move off into another computer by itself, okay? Then we have ransomware. So ransomware is the name given to a class of malware that encrypts or threatens to delete your files, takes over your computer, encrypts your computer, and then tries to hold you to ransom for your files. So this is most dangerous in banks and things. This tends to happen quite a lot. Now, the best way, or the two best ways I can think of to deal with this are, one, to take regular backups, and two, to train the staff to know what to do in this situation. If you take regular backups and someone takes over your computer, you can say, well, that's fine, I'll just delete and reinstall my operating system because I've got everything backed up anyway. Okay, that would be sensible. And if you've trained the staff to do that, then you should be fine. Now, if someone has everything saved on their computer and then it's taken over by a ransomware attack, and let's say you've got some crucial work on there, you may end up having to pay, okay, to get it back. So there's no way around this. If it's encrypted, even for a big bank, if they get caught out, they would probably have to pay to get it back. So there's ransomware. Spyware is just a term used for software to snoop on a computer. Keyloggers, webcam hijacks, microphone hijacks, things like that are spyware. A keylogger is just a device that can save keystrokes on a keyboard. It can be hardware or software. It can be like a little USB stick, or it can be a software program. And there's a little explanation about them. Webcam and microphone hijacks are just taking over control of someone's webcam or someone's microphone. Password attacks. Now, this could be trying to force your way in by guessing a password on a system. In recent years, we're trying to move away from using passwords to using multi-factor authentication. So as well as having a password, you have a code or something that you put in, or use your fingerprint on your phone. Just because once someone's got your password, it can be very easy for them to take over a system. So we've got some password dictionaries, are giant lists of words that we can run, and we can try looking in the dictionary and then run it against a system to see if we can find a password. And this is very useful for people who use obvious passwords, like password 1, 1, 2, 3, 4, things like that. Not so common anymore, but it used to be a few years ago. Right, drive-by downloads. So it says here, gone are the days when users had to click accept a download or download an installation of software in order to become infected. Now, just opening a compromised web page could allow dangerous code to install on your device. So users just need to visit or drive by a web page, and that is enough for some malicious code to land on their computer. So it's useful in your browser to have some kind of spyware or JavaScript blocking working. The Brave browser that I've started using recently is good for this. It has a concept of shields. So it's got quite some good kind of malicious code blocking facilities built in. Okay, it says the best advice here is to avoid visiting websites that could be considered dangerous or malicious. Then we have DDoS attacks. Okay, so a DDoS attack, a distributed denial of service attack, is just lots of things attacking one thing. Okay. Now, we covered this in Cisco Network Essentials, so I don't know if this is entirely relevant here, because we did cover DOS and DDoS in Chapter 7 of Network Essentials. So we'll not go into this too much, what a botnet is and what a zombie is. Right, so a prominent tool in denial of service attacks is called low orbit ion cannon. And it's an open source application designed to flood target sites with requests. So remember, a DDoS in some cases is malicious, but sometimes we can use the term DDoS just to describe something being overloaded. So for example, I work for a company, and sometimes they have tickets for shows going on and their web hosting can't handle it. So as soon as we put a ticket for a big show on, everyone tries to buy the ticket at the same time. And what I usually say is the website's been DDoSed, it's down, because everyone's trying to access it at the same time and the server can't handle it. However, in this case, it's meaning it to be like a weapon of choice. Okay. Another example of why you might use this is, say, an environmental group of hacktivists might want to DDoS a company they don't like, an oil company or something like that. Right, an advanced persistent threat. So the last topic is a prolonged attack on a specific target with the intention of compromising the system in some way, as the name suggests. So these are serious threats, and they're a threat that's going to go on over a long time. Okay. Some security professionals reserve this term for cyber attacks by governments or other powerful organizations. So sometimes we might call these different actors in an attack situation. So let's say we have, you might have international hacker organizations or international groups of hacktivists. You may have nation states trying to spy on each other. So, and you may just have low skill kids, script kiddies, trying to run attacks on things. So those are just some things to consider. Okay, different actors can do different things. So that's the theory for topic 1. Now, what I'm going to do is I'm going to jump over to an Excel file that I have here. Okay, and I think I've assigned everyone a question. Malware is a term made up from 2 words, malicious and software. That's an easy one. Incorrect to describe any malware. It is incorrect because a virus is only one type of malware. Malware is any type of brilliant. Describe 2 characteristics unique to a computer virus. A virus is unique as it typically can replicate itself. Yes, very good. Describe 2 methods. Spread, clicking a link or downloading a file. Clicking on a link or downloading. Yes, okay. Computer system has been compromised by a virus. Oh, that question doesn't make any sense. Let me look at the questions here. Let's go. Let's show part 1 as well. And at the very end of this part 1, I think that's question 5 or something. Computer viruses, describe 2 symptoms that might suggest. All right, so we're missing describe 2 symptoms that might suggest. So let's just pop that in. Describe, oh, it's there. I just had to double click. Right, it runs slowly. Yeah, that's perfect. In the context of computer viruses, explain what is meant by the term replication. Replication refers to, oh, Duncan, you're saying you can't say your name. That, Duncan, is I think because you were late today. So I didn't have time to assign you something. But I'll remember to assign you something next week if you manage to turn up on time, right? Okay, explain, where are we? What is meant by replication? Copying itself. That's a perfect answer. Why Is it more difficult for antivirus? Because they use a different order. Right. I don't know if that one's quite right. So I'm going to highlight that. I think home. Let's just highlight this one just now, amber. Okay, and let's highlight these ones up here as green. Okay, so I'm not sure about that one there. Okay. Explain how a virus file differs from a boot sector virus. Okay, the boot sector virus infects a boot. This is an important part of the disk where, along with the information, the file virus. Okay, very long answer though, but okay, I'll give you that one. That's right. Put that green. Okay, right. Signature detection. Compare the code with the database. Yep. Monitoring. Okay, the keyword for this one is behavior. Okay. There. That makes that one correct now. Just that one extra word. Right. Moving our way down. Describe how a Trojan pretends to be legitimate but has malicious intent. Right. That's not quite correct. So we'll put that one in amber just now. Let's move down. Explain what is meant by a backdoor, passing a security. Yep, that's correct. So let's go green for that one. And we've got, how does a worm operate? Let's have a look in here. Malicious computer program that spreads computers by itself, launched by the person. Okay, yeah, that's good. This one, describe 2 examples of spyware and describe how each might be used by criminals. Yep, that's good. Let's do that one. What is a drive-by download? Unauthorized. That looks right to me. Let's get rid of this picture. State 3 characteristics of strong password. That looks good. Password, I did that one, so it's right. Should have gave that to Duncan. Crack and gain. Goal of gaining access is to, that looks good. Place of passwords. Oh, okay. What's this? Biometric systems are used. Describe 2 biometric methods of authentication. Fingerprint and something else. That looks good. Let's delete that. Yes, very good. Describe how a DDoS attack. Yep, that looks good. And ransomware works by encrypting. Yes, so that is, I'm happy with that. So the 2 that I want to come back to in here are this one. Okay, so why is it more difficult for antivirus? Okay, computer viruses often camouflage. Describe 2 camouflage techniques. Okay. Because they use a different order in which way the code runs to be detected. Okay, but that's not really a technique, is it? It's not really a camouflage technique that a virus might employ. Okay, so a camouflage technique would be like hiding inside a legitimate email or file. And sorry, I don't know if I've spelled legitimate correctly there. Can we get some spell check down here, please? Legitimate. Hang on. Oh, it's legitimate. Speaking of which, did he not leave earlier? Mate. He's gone, Mr. Mate. Hiding inside a legitimate file. Okay. Would be one way. And how else could you camouflage a virus? Try to think of another one. Okay, virus. Virus camouflage techniques. I know. Hiding in or disguised as a real program. Okay, something like that. Those two would be legitimate techniques, right? This one, Alistair, describe how a Trojan differs from a virus, right? Trojan pretends to be legitimate but has malicious intent. A virus requires a right. Nah. Right. So a Trojan is a one-time hidden payload. Okay. Disguised and often attacks only once. Okay, and the virus definition is fine. So the key with a Trojan is it's hidden and it attacks once. Okay. Oh, I think the connection might have just dropped. Right. Good. Okay. Try to highlight this as green 100 times. There. Let me zoom out now. All right. So what I'm going to do is I will make this file available to everyone. Yes. I'll make this file available to everyone today. Okay. So this is us covered exercises 1 and 2, and we've done it quite quickly as well. Okay, it's much less tedious than doing it yourself. So let me just turn off sharing for this just now so no one can break it. Allow editing. Anyone with the link. Specific people apply. Will this kick you all out? I wonder. No, you're all still in. Okay. Okay, keep this as it is because we need this. We'll need this for revising for the test later on. Okay, I'll make it available to everyone. Okay, so that's topic 1 of the theory covered. Okay, so now what we need to look at, all right, is the practical part 1. So I'm still recording this, so I'll be able to make this available a bit later on. But lab 1, okay, is a Kali installation. All right, so let me open up lab 1. Now, this information here was written by the SQA, and you can take some time in your own time to read through this. Let me close down some of these windows. Now, what I want you to do for lab 1 is have a little read of this about Kali, and then download the ePortfolio template from the Moodle. Have VMware installed. So up to here, you don't even really need a computer. And then move to part 1. Okay. So in part 1, what we're going to do, and this is, don't do this just now because this is a big file, all right, is you're going to go to this page here and you're going to download the Kali 64-bit net installer. Now, I tried to download the torrent a little while ago and that didn't work. So download the net installer file, just a direct download. Maybe the torrent will work for you. It's about 400 meg, so I wouldn't start it now. And there, as I demonstrated earlier, is a SHA-512 sum. Yeah, it doesn't matter if you downloaded the 4 gig one. That's fine. It's just, obviously, it's much slower. So this is much quicker to download this. Anyway, if you want to download the full, wherever it is, 4.1 gig, that's okay. But I think you just need to download the net installer. Once you've done that, okay, took 4 hours. Downloaded it and it took 4. Right, the 400 meg one would have only taken 1/10 of that time then. So 200 would have only taken you 20 minutes to download the. Anyway, right. So this here is telling you what to do when you have that file. Now, let me just jump over to VMware and I'll show you. And you don't need to do this right now. Okay, this is what I want you to do this in your own time. Okay, we're going to go to create a new virtual machine. Now, this wizard will come up we always generally in this subject choose custom. Okay, now what we're going to do is follow the lab. So let's start VMware, choose new virtual machine, custom, workstation 16, compatibility, use ISO image. So we go back to VMware, okay, use workstation 16, okay, compatibility, use ISO image. Now, at this point, you're going to create a folder on your computer, or VMware will have created a folder on your computer called VMs or VMware or something. I will show you my computer now to show you what it does, but remember I'm not on Windows, I'm on Linux. So I have a folder called VMware in my home directory. You should have a similar folder. Inside here, you should place the Kali ISO that you downloaded. Okay, so in here, I have my Kali ISO here. So we keep everything tidy in one folder. Okay, do not leave your Kali ISO in the downloads folder or on the desktop. Okay, put it someplace sensible. If you must make a new folder, make a folder called ethical hacking. VMware already creates a folder though, so I've gotten into the habit of just using the folder that VMware creates. Right, so let's browse and choose, okay, the Kali ISO. Now, all we do after that is we follow the steps shown out here. Now, if you only have 4 gig of RAM, as it says here, set the total to this amount. But anyone else who has 8 gig of RAM or more, use this amount of RAM for your virtual machine. Everything else should be fine. Just leave things as default and work your way through. Now, once you've finished the VM setup here, okay, you'll then need to follow through the steps in the lab to install Kali. And I'm going to let you do that yourself, okay? Now, when you see this camera, this generally means you need to add something to the e-portfolio, okay? When you see this. And really, once you've finished the installation, that's it. Okay, that's the end of step 1. That's the end of part 1. Okay, so that's it. Right, so I'm going to leave that with you to complete. Okay, and what I'm going to make available as well is Lab 2. Now, Lab 2 is pretty easy as well. Okay, so I'm going to move it up to here. And I'll open up Lab 2. Now in Lab 2, this will assume that you have Kali running. Okay, and all this is getting you to do is look at the 3 different methods of networking in VMware. All right, you need to complete Lab 1 and update the ePortfolio before moving on to this. But the purpose of this lab, and it's quite short, is just to familiarize you with the 3 different modes of networking. Okay, host only, bridged, and NAT. And it will explain in here how to manage those. Okay, very quickly, let me just show you a Kali machine that I set up while I was writing the material for this. So let's just go library, Kali, start, close that. Close that. Right, so while that's booting up, I'll make that available. And now let me just move this down here actually. And let's do Lab 2. We'll make this subject available. And we'll hide this topic just now till we get onto that next week. Let's move that to there. Okay, so that's Lab 1 and Lab 2 available. Right, I'm going to stop the share now. Let me just log into Kali and I'll show you what it should look like when you've installed it. Okay, here is what it looks like when it's installed. All right, And for example, let's have a look at lab 2, right? If I jump over to lab 2, it tells me that there's 3. The first command I need to put in is IP address show, okay, by clicking on the terminal. So all I do is I type IP address show. All right, and there's our IP addresses coming up in purple.